The most basic four-sided polygon is called a quadrilateral. And the only thing that we know about a quadrilateral, we don't know anything about its side lengths or whether or not the opposite sides are congruent or the opposite angles are congruent. The only thing we do know is that from the sum of the interior angles formula, 180 times n, which is 4, minus 360, gives us the sum of the interior angles of a quadrilateral as 360. We also know, as with all polygons, the sum of the exterior angles is 360 as well. So if all we know about this polygon is that it's 1, 2, 3, 4-sided, that it's a quadrilateral, the only thing we can do to find the largest angle of this polygon is use the fact that all the angles, x, 2x, 3x, and 4x, all of them have a sum of 360. So combining like terms, we get 10x equals 360, which gives us x is 10. To find the largest angle, we use the angle with the largest coefficient, 4. So 4 times 10 gives us the largest angle, which is 40 degrees. If a quadrilateral has both pairs of its opposite sides that are parallel, so if we have a pair of opposite sides parallel here, a pair of opposite sides parallel here, then this is called a parallelogram. And a parallelogram possesses quite a few properties that are important. The first one is that both pairs of opposite sides are parallel, and that's where the parallelogram gets its name from, is that the fact that both of its opposite sides are parallel. The next property is that the same side interior angles are supplementary. So let's say that this is my parallelogram. We know that the opposite sides are parallel, and from that you end up having consecutive interior angles or same side interior angles, which we learned a long time ago that same side interior angles have a sum of 180 degrees. So these two angles would also have a sum of 180 degrees, and these two right here and these two right here would have a sum of 180 degrees. Both pairs of opposite angles in a parallelogram are congruent. So let's say this is my parallelogram. This angle would be congruent to its opposite angle, or the angle across from it. And this angle would be congruent to its opposite angle, the angle across from it. Both pairs of opposite sides in a parallelogram are congruent. So this side across from this side, they're congruent, and this side across from this side, they're congruent. And the last property for a parallelogram is that the diagonals bisect each other. So what that means is that this diagonal, let's call it AB. This diagonal cuts, let's call this CD, cuts CD in half. And then CD cuts AB in half. And we'll call that point P. So CP is congruent to PD, and separately AP is congruent to PB. Now here's why you're going to have to know these properties by heart. Whenever you're given a parallelogram, and let's just say for our purposes that the next quadrilaterals are all parallelograms. Given a quadrilateral or a parallelogram, you have to know which way to solve and why you're solving something the way that you are. So in this first one, in order to find the value of z, we're going to use the fact that both pairs of opposite angles, or sorry, sides, are parallel. So this side is parallel to this side, and BC is parallel to AD. And what that ends up doing is creating our parallel line relationships. Remember, we had alternate interior angles, we had consecutive interior angles, we have corresponding angles which won't apply in parallelograms, and then we had alternate exterior angles which also won't apply in parallelograms. So the ones that are important are these alternate interior angles, which you're going to see if we highlight our Z this way. we have this 30 degrees, which is congruent to 3z plus 6. So because AB is parallel to DC, we can know that 3z plus 6 is equal to this 30 by alternate interior angles. And when I solve for z, I get the value for z as 8. The next property that you're going to see a lot is if we know that this is a parallelogram and we know that the same side interior angles are supplementary. So the two angles that are right next to each other on the inside of the parallelogram, they're going to have a sum equal to 180 degrees. So I can say 4x plus 2x minus 6 equals 180 degrees because the same side interior angles are supplementary. And when I solve for the value of x, I get 31. The next property is that opposite angles are congruent. So if this is a parallelogram, we actually could solve it two ways. We can set angle M and angle L equal to 180 because they're same side interior. Or we can use the fact that opposite angles, so these two are opposites, opposite angles in a parallelogram are congruent, or their measures are equal to each other. And when I solve for x in this case, I get 38. Okay, the fourth property. In a parallelogram, the opposite sides are congruent. So this side here is congruent to this side here. So y plus 8 is equal to 5y. And when I solve for y, I get 2. The last property of a parallelogram is that the diagonals bisect each other. So that means that this segment is congruent to this segment, and separately, if they'd given us those values, this segment would be congruent to this segment. So because the diagonals bisect each other, because this is the midpoint here, that means that 3z minus 4 is equal to z plus 5. Okay, and when I solve for the value of z, I get 4.5. Okay, if we have a parallelogram with each interior angle equal to 90 degrees, we then have a rectangle. So if we know that this is a parallelogram and each of these angles is 90 degrees, then we know that it's a rectangle. On top of having 90 degrees in each angle, a rectangle will have the diagonals that are congruent. So if this is my rectangle, I have A, B, C, D. If I know that this is a rectangle and I have diagonal DB and AC, that means that these diagonals are congruent. The whole diagonal, AC, is congruent to BD. And then of course it's important to remember that each interior angle is 90 degrees. So the first property, the diagonals are congruent. It says DEFG is a rectangle. If FD, so the whole diagonal FD, is 3x plus 7, and the whole diagonal EG is x plus 5. In order to find EG, you have to know that in a rectangle, the diagonals are congruent. So FD is congruent to EG, and then substituting the values in, 3x minus 7 equals x plus 5. So when I solve for x, I get 6, and then to answer the question to find EG, I would substitute that 6 back in for x. So EG is going to equal 6 plus 5, which is 11. Okay, the second property, each interior angle is 90 degrees. If we know that the figure is a rectangle, and EFD, E to F to D here, is 2x minus 3, and DFG, DFG here, is x plus 12. Well, in order to find x and then the measure of EFD, we would use the fact that these two angles together are 90 degrees. So 2x minus 3 plus x plus 12 is 90 degrees. So when I solve for the value of x, I get 27. in order to find out what EFD is, I would plug 27 back in for x. So 2 times 27 is 54, minus 3 is 51, which gives me the measure of EFD. Okay, the next special parallelogram is a rhombus, and that's going to be a parallelogram with all sides congruent to each other. Doesn't necessarily mean all the angles are congruent, but it does mean that the sides are congruent. The first property about a rhombus is that the diagonals are perpendicular. That means where they intersect are all right angles. The diagonals also bisect each interior angle. So if this is a rhombus, it cuts this angle in half, so 2 congruent parts. It also, if we drew another diagonal, would cut this angle in half and this angle in half. So let's use the first property. Diagonals are perpendicular in a rhombus. ABCD is a rhombus. The measure of DPC, so here, is 3x minus 5. Well, if this is a rhombus, then all the angles intersected at the diagonals are 90 degrees. So this 3x minus 15 is 90 degrees. So in solving for x, I get 35. The next property of a rhombus is that the diagonals bisect each interior angle. So if angle ABP, A to B to P here, is 2y plus 7, and PBC, P to B to C here, is 45. Well, in order to find y, we would use the fact that it's a rhombus and each angle has been bisected. So each angle has been cut into 2 congruent angles. So that means that 2y plus 7 is equal to 45. Okay, so in solving for y, I get 19. And finally, the last parallelogram that we will study is a square. A square is a combination of a rectangle and a rhombus. And of course, it's also a parallelogram because it is a rectangle and a rhombus. So it has all the properties of a quadrilateral, a parallelogram, a rectangle, and a rhombus. So on top of knowing all the properties, you have to know that a square satisfies all the properties. Now, in order to keep all this straight in your head, you may want to make flashcards and actually study them. Because as soon as I say rhombus, you have to be able to say it and write it, that in a rhombus the diagonals are perpendicular, the diagonals bisect each interior angle. For a rectangle, you must immediately be able to tell me that the diagonals are congruent and that each interior angle is 90 degrees. And then for a parallelogram, you have 5 properties to know and be able to apply algebraically